Hydrogen, everybody knows. I think must have come across either in the laboratory or in the design or in the operation, or it's a very light molecular weight tube, boiling point, very difficult boiling point, minus 252.8. It is very difficult to liquefy hydrogen. It's colorless, odorless, highly flammable, and one of the most hazardous chemical to be handled. It has a varied application: fertilizers, ammonia, hydrogenation, production, oil refining, hydrotreating, hydrocracking. It is also a byproduct from the reactions like dehydrogenation. For example, now everybody is talking about propylene. Propylene has been one of the rare commodities. It's to be imported and difficult to import. Propane dehydrogenation to convert propane into propylene has been very important, which gives you a lot of byproduct hydrogen. Maybe you can set up a big ammonia plant based on that byproduct hydrogen. In the rocket science, hydrogen is used as a liquid. Automotive, Germany started using hydrogen as a fuel in the cars. Maybe after a few years, that will come in India as well. So there are not many applications. Hydrogen can be produced from fossil fuel, coal, heavy hydrocarbon, naphtha, biomass, natural gas. Unfortunately, all these hydrogen sources are with carbon, and that emit carbon dioxide, which is creating a huge loading on the environment in terms of the GHG gases. And I think that is one of the major reasons why now everybody is talking about green hydrogen, to reduce the emission of green hydrogen on the Earth's planet. Global hydrogen production is almost discharging almost 920 million tons of CO2, which is of course only 2% of the global emission. And in India, we are consuming 6 million metric tons of hydrogen per year in refineries, in production of ammonia, in production of methanol, and all other chemical production where hydrogen is as an intermediate raw material. And this is the area where the green hydrogen will prepare a very big opportunity. We will go to this next. Now, why this color? Why it is green? I mean, it is a colorless gas. Why do we say it is green? It is because of the raw material which is used for that. So, for example, gray hydrogen is something which is producing natural gas. Brown is something out of gasification of coal or heavy oil, because it is producing so much of carbon dioxide. That is why it is called brown. Blue is something where natural gas is used, but you go for carbon recovery and utilization. They call it CCS. Methane pyrolysis is again a technology being developed, and they have given some number to quasies. Pink is out of nuclear. I think recently a small pilot reactor has been commissioned in India, where hydrogen will be produced from a nuclear reactor. Yellow is something which you are talking, which is a grid and solar or wind, because solar is not sufficient, wind is not sufficient. That is why you use power from grid. That is why it is a yellow hydrogen. Green hydrogen is which is produced only from the renewable energy. Renewable energy is either wind, either solar or hydro. And why it is something which is in a very developing stage, and we really don't have much information on that. Now, how do we produce green hydrogen? The requirements are renewable power from wind and solar. And why this is important for India? Because we have a massive potential of 1100 gigawatt for wind and 748 gigawatt for solar. Out of that, as on today, this is a figure of somewhere June 2026, the solar is about 162 and wind is about 57. So you can say that probably we are 5 to 10% of the potential which is available in the country. So there is a huge potential available to get the renewable energy and utilize in a very useful manner. We are ranking third in the renewable energy capacity. The problem with wind and solar, they are seasonal. Wind is available when there is a wind, depending upon the season, and solar is only when the sun is there. It starts producing energy, goes to the peak, and by evening it becomes zero. Now what we are talking is that the industry which is going to use it is a continuous process industry. They require power for 24/7 for 308 days in a year or 330 days in a year. So it's very important that we have to combine the fluctuating, I would not say fluctuating, but a varying power supply with a user who needs a constant power supply. So to meet the continuous power supply to electrolyzer and downstream various energy storage systems like BES, battery energy storage system, thermal storage, hydropower generation. Specifically in the thermal storage, the excess power is utilized for example, in carbon dioxide or molten salt, and when we require the energy, it will be converted into steam. It will drive a steam-driven generator, and power will be available. In case this is not to be done, we can utilize the excess power through a hydro system. Whenever the excess power is available, we utilize that to lift the water to certain height. And then when the power is in short supply, we utilize that to convert that hydrostatic head into electric energy through a turbine. At many places, this is being utilized as a part of energy storage systems. But battery energy storage system is a very versatile one, which is reliable one, and I think most of the development is now taking place on this one. Water is another input. We require about 15 to 30 liters per kg of hydrogen, which is required for water purification, cooling water requirement. This has to be a DM water or an ultra pure water as decided by the type of the electrolyzer you apply. This is a simple sketch. A renewable energy is generated. It is going to electrolyzer. Electrolyzer is producing hydrogen. You distribute that hydrogen or store hydrogen, and then utilize wherever, either in chemical industry or in automotive or whatever way we want to use it. To say, the first part is the renewable energy, that is wind and solar. Second part is making it as a constant supply is a battery energy storage system or any other storage system which regulates the requirement on a 24/7 basis. Then comes the electrolyzer, and then comes the downstream product. Now, as far as electrolyzers are concerned, there are several electrolyzers available. They are like caustic soda electrolyzers. There are alkaline electrolyzers, proton exchange membranes, anion exchange membranes, solid oxide electrolytics, SOECS. Mainly their variations are in terms of their capacity, in terms of their efficiency, because when somebody is selecting electrolyzer for his requirement, our consumption per ton of hydrogen or per kg of hydrogen is very important, because that is a major variable cost. Second is the cost of the consumables, because certain electrolyzers require very costly catalyst and electrolyte electrodes. So depending upon that, an has to select what temperature you want to use, what pressure you want hydrogen, what are your requirements, what is your capacity of electrolyzer. That will decide the selection of the electrolyzers. As I said, a solar hydro, then there will be energy storage, there is a electrolyzer. Either you can have hydrogen storage or directly use it. Hydrogen storage, I said, because boiling point is minus 253 degrees centigrade. It is very difficult in terms of cost. You can always liquefy hydrogen, but then bringing temperature to minus 252 degree is really a huge operating cost. And then you require a very costly storage because you have to store liquid hydrogen at atmospheric pressure with this temperature. Then it can go to your ammonia process. If you want to produce ammonia, then you require air separation. That we'll discuss later on. As I said, renewable energy is wind energy, solar energy, hydropower. Wind energy is seasonal and wind speed dependent. Solar is sunlight dependent and varying during the day. While hydro is available around the clock. We'll discuss one example of hydro in the next slide. Fuel cell is an electrochemical device that converts chemical energy of a fuel directly into electricity. For example, these days we are talking of the hydrogen run electrical trains. The trains which have been started by government of India, they are working basically on this principle that you have a huge storage of liquid hydrogen and then you have fuel cells and that runs the engine of the battery energy storage. We already discussed. The components are the inverters for power conversion, smart control system, and it helps in storing excess power and stabilize the power grid. This is a typical diagram of an alkaline hydrolyzer. There is a cathode and anode, and you produce hydrogen on cathode and oxygen is excess. These days oxygen, there is no requirement. Maybe someone will definitely work on that and find out how this oxygen can be utilized because you get a pure oxygen. Now this is a comparison of various electrolyzers. If you see the power consumption is varying from 40 to 65. SOES, which is a solid ceramic electrolyzers, is consuming less than 40 kilowatt per kg of hydrogen, while the alkaline is the highest, 50 to 65. Most of the projects which are coming up are at present based on either alkaline or PEM or SOES. Alkaline are highly matured, that technology is very well established, while the SOES are in a pre-commissioning stage. Cost-wise, alkaline are the lowest, while the SOES are the highest. These are some requirements of you can see that they require very precious material like nickel, cobalt, iridium oxide, cobalt oxide as a part of anode or cathode. This is one catch area. This material is not easily available, and I think India has a lot of import of this material. Precisely for this reason, the people who are developing this, for example, Chinese and America, they virtually hold over all the resources where this material can be imported, because this is going to be a future requirement, and availability of this is going to be decide the cost of electrolyzers in the user country. There are major suppliers: John Cocktail, AM Green, Net Hydrogen, TK Group, Siemens. For us, important is last two, Larsen and Toubro. They have started manufacturing this. They had recently a pilot plant at Hajira, and I think they are going in a big way, and they are going to have a capacity maybe 100 gigawatt after a few years. Reliance is also working on that, because this is going to be one of the most critical cost component element of the green hydrogen process. And that is why their availability domestically is very, very important. Now, if you see these steps, water is purified, treated and filtered to remove all minerals and salt, everybody knows. Renewable power is generated and stored at remote or nearby site and is fed with the electrolyzer. This is a very important point. For example, I want to put up a green hydrogen project with a input of 1000 megawatts power. And I decide to put it in Baroda because Baroda we have ammonia requirement in GSFC and other places. Power is available in Kutch because I am going to set up the wind power in Kutch or solar in Rajasthan. And then I utilize the grid to get that power into Baroda. That is feasible, it is being done. We set up, when I was at GSFC, we set up 150 megawatt power, wind power at various locations of Saurashtra, and utilize that power in Baroda and then in our Sikka unit, and maybe that time in Pavilion possible. But major problem as on today is that grid has been overstretched. The availability of grid has been a very, very problematic thing, and if everybody start putting so much of power into the grid and take it out at a distance, it is really a problematic, not only in terms of the electricity loss, but it is a problem of the grid stability, other costs and several factors. That is why today everybody is talking about a coexistence. Solar power is there, wind power is there, and if they want to produce ammonia or methane or anything out of that, that plant is set up nearby so that they become a coexistence plant and they are not required to be dependent on the state electricity board. Now, once all this is done, water is splitting to hydrogen and oxygen. Hydrogen is separated, I said as it is earlier slide. It passes through a drying system to remove residual moisture. And if required, for example, if some oxygen has remained, then oxygen is not acceptable to downstream industry. You have to go to some sort of purification system. But that is a industry specific requirement. Clean hydrogen is then compressed and sent to users. As I said, it can be stored at high pressure, but you can imagine that you require a massive volume of a high pressure hydrogen storage, which is almost like a bomb in that area. Best way is to liquefy it, but the cost is an issue. Best option would be to transport through the pipeline. Today, there are not many pipelines in the country, cross-country pipeline, but in US there are several cross-country pipelines where Linde, Praxair and other air products, they are producing hydrogen, they are putting into the pipeline like what the natural gas, HBJ pipeline of India. But this will happen one day that maybe you will see in the map of India a mushroom of pipelines carrying hydrogen, maybe compressed biogas and things like that. So this is for the end use of that. This is a simple diagram of the electrolyzer. I said there are a drying system, compression and things like that. The biggest discussion today is on the cost of hydrogen. Grey hydrogen, which we produce from natural gas, is costing about $1.5 a kg. I guess this is based on a natural gas price of something like $6 to $8 per MMBTU. This is my guess. Green hydrogen in India, depending upon because it is green hydrogen anywhere is going to be dependent on two factors. One is the cost of the electrolyzer, and second is the cost of power. Today in India, the renewable energy cost is something like 3 to 3.5 rupees. Maybe Thakur Saab can tell more about that. But this is if you buy it from somebody, a developer farm like Suzlon is doing or other people are doing, this could be the cost. If you do it on your own, and maybe on a massive scale that cost can go down. So that cost is one, and that is why the green hydrogen cost is around 3.1 to 3.78, so that is about 1,600 rupees a kg. Recently in Panipat L&T won a contract with a price of 4.6. That's really very high price. How do we reduce this price? One is get cheaper wind and solar. So you produce, you have your own wind farm and solar farm. Have a BES, battery energy storage system. Then probably the input cost of power could be something like 2 rupees to 2.25 rupees, and that will dramatically reduce the cost of hydrogen. Higher RE plant utilization means you utilize all available renewable energy, then also you get a lower cost of hydrogen. As I said earlier, the electricity cost is very high. I mean, the cost of that electricity in the contribution of the total cost of hydrogen is very high, which is about 65%. The electrolyzer cost is about 15%. Finance, interest, other costs are nominal. So essentially, it is the cost of electricity and the cost of electrolyzer which is going to decide the cost of hydrogen. So what should you do? Lowest RE cost. Put up a massive wind farm and solar farm, do a very smart transmission with a utility scale BES, then you can reduce the cost of power. As I said, co-located RE and electrolyzers. Don't put them 100 kilometers or 200 kilometers apart, maybe 5-10 kilometers apart. You find out. I think everybody is doing that. Whatever projects are right now coming around Kakinada, whatever are coming around Kutch, are based on this concept. They are not going for an independent RE much away from their main plant. Low cost of electrolyzer, I think the L&T and Reliance and Adani, they are for this, and I am sure that their efforts will reduce the cost of domestic electrolyzers. Maximum domestic input in making of electrolyzer, no need to discuss on that. Stake efficiency improvement is made with power per kg of hydrogen. High plant utilization, affordable finance, policy initiatives, our government is taking care of that. More than 48 countries have declared their hydrogen mission as what government intend to do and what supports them. It will be available from them. We will have a separate presentation where we will see how Gujarat government is working on that. So these policy initiatives are also helping in reducing the cost of hydrogen. Efficient supply chain is one good factor for making a more cost-effective hydrogen. How we are going to be benefited, or how we are required to have it right now out of comfort zone or out of a requirement. Green ammonia is not new to India. Those, I don't know how many are of my age in this group, but in 1960, the Fertilizer Corporation of India started an ammonia plant of 400 tons per day capacity, and the plant was based on the electrolyzer operated by hydropower from the Pakranangal dam. That plant continued to operate up to 1978, and when they switched over to fuel oil, that plant was shut down. But similarly, many plants were there in Finland, in Europe, in America, but then slowly, with the availability of and ease of natural gas, transportation of natural gas, these plants have been shut down. Today, hardly any hydrolyzer, any ammonia plant is working on a hydrolyzer. Large import of costly natural gas. See, The natural gas which is available to the Indian fertilizer company, those who are producing urea, I think it is about 2.5 to $3. Last, am I correct?
Yes, sir.
Huh? No, that is the FGM case. Okay, now I'm maybe the figure which I'm talking is very old. But against that, if you take LNG, maybe government gave reimbursement, but that may be available at $8, $10, $12, and maybe last few months it might have got to $22. So that is really a very problematic thing, and this variation in price is restricting the production of hydrogen, ammonia, methanol, and we have to import more of that, and the prices of this import material has also gone very high. Ammonia, which was available at a price of with a band of say $300 to $500 a ton, has gone to almost as high as 1,000. Now it is risky. Maybe again go up depending on what Mr. Trump declares. But this is the situation. So the industry is dependent on these wide variations which are unpredictable and which is a very deep effect on the operation and finally the economics and the availability. As I said, the Gulf War has created a big bottleneck for natural gas availability, and of course the need of reducing the greenhouse gases for better environment for future generation. I think these are the reasons why the green hydrogen and beyond, ammonia, methanol, and whatever we can produce out of that is going to be beneficial, not only in terms of cost, but in terms of improving the environment. Urea is made out of ammonia. Ammonia and carbon dioxide, which is generated as a byproduct from ammonia plant, is utilized to produce urea. India is producing about 28 million tons urea per year, and this could be a good candidate for making green urea, because you already made green ammonia out of green hydrogen, but then what's about carbon dioxide? You start capturing carbon dioxide from all coal plants, cement plants, and wherever steel plants, wherever fuel is used, and carbon dioxide is emitted into the atmosphere. I am seeing that after many more years, maybe after 5 or 10 years, the way today we see the map of natural gas in India, there would be a similar mapping of natural gas, hydrogen, then carbon dioxide, and many such products which can be utilized on biogas, which can be utilized across the country. Somebody did a calculation that what could be the cost of this urea. They said it was 500 tons, $500 per ton. And today we are importing almost 5 to 6 million tons of urea at a price of $500 per ton. Of course, recently, last few months figure you see, they have bothered not to even touch the Indian tender, and they are just coming back blank because nobody wants to offer this material. The prices have gone very high, they are available at $800. So this could be a very useful and economical way. It is in development stage. A small pilot plant has been set up by 2-3 companies, I think BHEL and somebody else. They are trying to put up a small urea plant, green urea plant. But then I think eventually a big urea plant will come based on this concept. Government is giving a lot of initiatives, and recently PDR invited all fertilizer industry to find out how they are interested to set up this plant, what specific things they want from government, and I think probably in a time to come, a blueprint from the government would be available to direct this setting of a green urea project. just making a calculation. We talked about natural gas price. We talked about the high capex of the renewable based, RE based ammonia plant or a hydrogen plant, and we talked about the cost of renewable power. I was just making a comparison for a bill for a 300 tons plant, that if the natural gas price changes from $10 to $25 per MMBTU on a GCV basis, the levelized cost of production of ammonia could be in the range of 44,000 rupees to 84,000 rupees. So $450 to $850. As against that, a RE based green hydrogen and then green ammonia plant with a price of 3.5 rupees per kilowatt, the ammonia price could be in the range of $808 to $858. But if the RE price, goes to 2.5, that goes to 65 to 70,000 rupees, or say $650 and $700. Still, if we get a renewable power at 2 rupees, probably this could be a ammonia comparable with a $15 per MMBTU based product. That means if the gas price is about $12 to $15 per MMBTU, the renewable green hydrogen and green ammonia is going to be economical. That is why I said in the beginning that the cost of the electrolyzer and the cost of electrical power, means RE, is going to decide the development of this industry in the country. As I said, green hydrogen, there are various applications. I have limited to only ammonia, methanol, urea and melamine. Two global projects are, many are coming, but these are worth noting. A project in Oman, which is going to be in a 3-phase, and the capacity of that is going to be almost a 1 million ton per year of ammonia. And I don't have a precise figure on the capex, but that is going to be something like 7.5 to $8 billion. They will have a wind and solar with 800 megawatt hour BES, and they will have electrolyzer. Each electrolyzer has a capacity of 80 megawatt. They are scheduled to be implemented in next year, 2030 and 2033. This is a very prestigious project. Another is a NEOM Air Products. Air Products is a famous name. It's a US-based company, and their border office is not far away from here. They are setting up a 1.2 million tons per year ammonia plant in Saudi Arabia. They have a 4 gigawatt combined solar and wind, and capex is near to 8.4 billion, and it's expected to be ready by 2027. I have a little doubt on this date because there were some issues, and probably 2028 or 29 this can come up. Let's see what is happening in India. ACM, Cleantech, Jackson and SCC Intra, these are the developers at various places. Most of them are in Kakinada, in Kutch and maybe in Rajasthan. They invited offers from Indian fertilizer companies, mainly those companies who are importing ammonia for DAP production or NPK production, namely IFCO, Coromandel, Paradeep Fertilizer, PPL, Oswald Krishna Foskam, then MBPL, which is again a company of Oswald, Indorama India, and all these manufacturers are importing ammonia from either from Gulf or mostly from Gulf, and they have now, I would not say they are exactly the contract, they are more than MOU agreements where the price of ammonia is going to be in the range of 64 to 49 rupees per kg. So if I convert into dollar, it is something like $490 to $550. These projects are likely to come up in next 2 to 3 years, and most of the DAP manufacturers will be benefited by this. The main reason that why is such a low price as compared to, we talk about a 300 tons plant, where price is about say $800, $700. This is mainly because of the large capacity. They are putting up a 1 million ton capacity plant, integrated renewable energy. So they are not talking of a split location. The plant, renewable plant in Gujarat, ammonia plant is in Maharashtra. They are putting coexisting side to side, and they have their own renewable energy farms. That is why they are able to make much competitive cost of renewable energy, which is about 2 rupees or 2 rupees and 15 paisa, and they tell like this price they are able to offer. This also includes certain incentives by the government of India, mainly for green ammonia. They are in terms of the fiscal, in terms of the finance, in terms of some subsidy and things like that. So this is the latest picture on green ammonia projects. As I said earlier, this gives how green hydrogen is connected with ammonia, urea and methanol. If you want to produce green urea, you require captured carbon dioxide, you require green ammonia. If you want to produce methanol, you can use green hydrogen and you take captured carbon dioxide to produce methanol. If you want to produce melamine, you take green ammonia, you take captured carbon dioxide and produce melamine. Melamine is in a concept stage, but methanol is really now in the offing and people are talking about that. Ammonia, you've already seen that certain projects are already under implementation. To conclude, massive growth of RA and large capacity green hydrogen ammonia is getting realized in India, as we see so in the earlier slide. Development of local electrolyzers will accelerate the growth, because so far they were all talking about imported electrolyzers. Success of green hydrogen project with only hydrogen or downstream together will be governed by smart integration of RE and downstream process plants. It is not just making modules, and one module you give to one EPC company, another you give to another EPC company, and third, then that is not going to work. It requires a seamless integration of the entire system. Why today everybody is talking about coal gasification? These are the hypes coming up. We should go for coal gasification. Many projects in India will become self-sufficient, Atmanirbharta and all that. India set up 3 coal-based ammonia plant and urea plant. Ramagundam, then maybe Baroni and maybe Durgapur. These were the 3 coal-based ammonia plants. And everybody knows that the Indian coal is the lousiest coal. It has 40% ash. And it is very difficult to, it's a nut. It is very difficult to gasify it without much problems. There will be many problems. These projects came up in early 60s and they were total failures. They were shut down after a few years without producing, maybe somebody produced something, but 1 or 2 plants didn't produce even a single drop of urea or ammonia. The main reason was technology failure and the integration failure. I got ammonia, coal gasification from somebody, ammonia from somebody, urea from somebody, utility from somebody. There was no integration, and that is why there were huge problems. And even today, when we are talking about coal gasification, Atmanirbhar, Pranavayu, we don't know what are the exact reasons, technical reasons for failure of these plants. So that is why for hydrogen, green hydrogen also, this is very, very important that RE, energy storage and the electrolyzer. Rest is all well established. If you want to produce ammonia, you want to produce methanol, it is all well established technology, and you give the input, you get a technology from a cupboard. So that sort of situation is there. But that integration of the front part is very important. As I said, green ammonia and methanol, because there is a huge import, they are the immediate targets. They are hanging fruits, as we call in energy conservation. They are hanging fruits. For existing plants like say GSFC, GNFC, where they are already producing ammonia out of hydrogen, they have or methanol, they have a good potential for revamping of their plant by incorporating a small unit of hydrogen. On a long run, we shall see full use of hydrogen in automobiles. But this is decided by the development of the hydrogen grid, filling stations and safe automobiles. Hydrogen being one of the most hazardous chemical, all safety requirements should be either at design stage, operation and maintenance stage. Then only this project becomes. Now to summarize, it is not a new technology, but it requires a lot of development on the front side as well as on the electrolyte side, and I'm sure that this will replace a large portion of imported natural gas for at least fertilizer production and production in the country. It is quite likely that hydrogen also will be quite utilized in the automobiles. When I was in India in 2013, their MD was coming in a car driven by hydrogen fuel. So in Germany, these are being done. Trains, we are talking now, India has started these these trains on hydrogen. Germany did this several years ago. Then again, I understood from a few days ago that they have stopped these trains. So this is a very precarious situation. Depending upon the technology, the success will be decided.
Recently, India launched the hydrogen train. What is the green hydrogen? Recently, India launched our PM, respected PM, launched the green hydrogen train.
Green?
Haryana.
You see, I don't know. See, whatever has been launched by Prime Minister is a hydrogen fueled electrical train. Now, from where this hydrogen is coming, I am not sure. It could be from refinery as well. So, I am not saying that this train is based on green hydrogen. It could be, it could not be. Because today we don't have such a large capacity where green hydrogen is produced. People are talking of so many plants. You will see a list in the next presentation. But very few are realized. Recently, L&T started.
The risk factor remains same, I understand. The risk, hydrogen being a risky affair, risk will be there.
Yeah. That is right. But then see, when LPG was available, people were reluctant to convert their car into LPG. They were preferring petrol. Even I was also one of them not to use LPG. Then after LPG, NG, natural gas came, CNG came, and you can see how people have adopted to that. So it all depends on the technology, the safety features you built into your system. You require a very safe hydrogen car. Otherwise, you are running with a bomb. So, but then similarly, petrol also is equally hazardous. Maybe the range could be narrow, Hydrogen is 2 to 74% range, explosive range. Petrol could be little less, but then still you. But at the end, it is the technology which gets developed is going to decide that.
So what is the basically it's electrolysis, no?
Yeah.
Electrolysis basically. So what is the hydrogen part for like percentage coming from the electrolysis process?
Hydrogen bomb.
Percentage of hydrogen is produced.
No. See whatever. See hydro.
Like from 1 liter or 1,000 liter.
No, it is very simple. See, molecular weight of water is 2 plus 6 is 18. Out of that 18, 16 is oxygen and 2 is hydrogen. So you put on electrolysis, you get 2 of that hydrogen and 16 of that oxygen. Oxygen remains unutilized and 2 you are using in whatever process you after drying, compression and purification. So theoretically, it is same. Only thing that depending upon the quality of water, depending upon the type of electrolyzer utilized, the service water requirement, cooling water requirement would change. That is why I said some 1.5 liter is required for kg of hydrogen, something like that. Okay?
So lot of water will be required.
Obviously.
Do we have that in India? Do we have that resource, natural resource?
No, see, it is not a question whether it is available or not. It is a question how do you balance it. See, now natural gas is also not available in the country. You are importing. You also can have various resources. I am sure that within a year or two, it is already there, but it is not taking as a mission the water conservation. Water conservation is very, very important, and we should have done that many years ago, but it is not being done so rigorously. And
The same thing applies to data centers. Lot of water is going to be used in establishing the.
now see, data center, you have to decide whether you have it or not. If data center is not required, don't use that water. If you have option against data center, see that. You have to just compare. So everything, whether you produce hydrogen from natural gas, you produce from coal, or you produce from nuclear energy, there is a advantage and disadvantage. You have to weigh it. As of today, what is apparently felt, I am using the word apparently, because one of the question mark in the electrolyte system is the use of precious metals, iridium, palladium, platinum, and their availability, their cost. That is going to decide in the long run. That you have to take care in your levelized cost of production and then take a decision. And that decision has to be based on what is the economics.
Precious metals is again a problem. Precious metals again a problem.
Yeah, that everybody knows. China and America is sitting on that, and we have to beg it. But then, say for example, now they are talking of cheaper materials. Lot of development is going on. I was just reading few days back that CO2 electrolyzer is now coming up. CO2 is available in ample. You can get it anywhere. You can extract it and use it. CO2 electrolyzer will get you so many chemicals, which otherwise you have to produce either from naphtha or natural gas. So, see, anything comes up, there is going to be a development requirement. Things are not just, this is not a simple thing. It requires a lot of development in all these stages. There are going to be several threats, like say precious metals is going to be one threat in terms of the operating cost, in terms of the availability. Okay. Now this is one presentation from Government of Gujarat in 2024. I thought I will just share this. The project concept and other things are all what we have already discussed. Whatever government initiatives are there, what price they are talking about, how much is going to be investment, and these are the rest. Maybe you can share the presentation. They can just read it like a newspaper. But this is something. This slide is important.
Reading Vibrant Gujarat Treaty 5, sir. Reading Vibrant Gujarat Treaty 5.
Which one?
2025. Reliance and Adani, they announced green energy projects of maybe 25,000 crores or so. So is it related to this same green ammonia, green energy?
No, I mean, your question is related to Vibrant Gujarat or to Adani?
To like the investment in Gujarat.
See, let us be very clear and frank. Whatever is being discussed and talked, that investment is not coming up for several reasons. People say whatever is being announced in the Vibrant Gujarat or otherwise, the investment is really coming up, could be of the order of 5 to 15% or 20%. Figure is varying. In fact, I have been a party to signing of several MOUs during Vibrant Gujarat, but few projects are coming up. We should see that, the purpose of MOU and announcement is essentially to take it further. Today I make announcement that okay, Adani will make a 25,000 crore coal gasification and downstream project in Kutch. Now this project may come up, may not come up. It may come up in a smaller scale, we do not know. But then every project doesn't get realized. Few projects get realized, few projects don't get realized. You know the story of Reliance. When after the Pazalganga plant they wanted to set up the refinery, they searched for almost 5 years to find out the location for the Reliance refinery. And initial location identified was Surat, somewhere near Surat. They spent good money, time and energy to see whether a thing can be set up over there. But then finally they decided that their plant has to come up at Moti Kavli in Jamnagar district. So projects would come, they would come late because everybody has their own money and they will definitely see what they get out of it. And today we know, after spending so much money for Surat location, then working for the Moti Kavli location, today what is the situation? So it depends how technology moves, how their technology is successful, and that will decide the investment. So not necessary that all which is being announced either out or in Vibrant Gujarat or Vibrant India or Vibrant Rajasthan or Vibrant Andhra Pradesh may come, may not come. It depends what is going to be the final investment benefit to the entrepreneurs. Now this is a small, not small list. It is a big list of various hydrogen projects which were discussed, decided or announced in 2024. GIPCL, Adani, NTPC, hydrogen, now it is coming to a small scale. Reliance is talking of electrolyzer, L&T is talking of electrolyzers, because that's very important. They don't want to produce hydrogen, but they want to produce a critical component of hydrogen plant. Similarly, ACME green hydrogen now, that is coming in a big way. ONGC, Renew Power, Karnataka Energy, Petronet, So these are the various projects, and you can see the investment and the capacity is quite high. And even if some percentage of this get realized, it is going to be beneficial. Not necessarily that all these will get realized. Okay, thank you. Any questions? I will try to answer. I should be expecting many more questions because this is really a very.
Hydrogen is going to be used for semiconductor chip production.
Pardon?
Semiconductor chip production.
Can you repeat your question, please?
Semiconductor.
Ah, yeah. See, semiconductor chips require hydrogen, but they require a much more pure hydrogen. So whether you produce hydrogen from natural gas, you produce natural gas, you produce hydrogen from RE or any other source, that hydrogen has to be very pure. Conventional hydrogen, which is used in the ammonia plant or in a refinery, is not suitable for semiconductors. The technology is available from Linde, Air Products, Air Liquid, to purify the industrial hydrogen to a much more pure scale, where the impurity level will be in a ppb level. So today, I give an example. When I was at GSFC, I was operating ammonia plant where hydrogen is produced as one of the intermediates. The hydrogen purity was 5 ppm of oxygen and 5 ppm of nitrogen, CO. That was
less than 10 ppm.
Total 10 ppm. Now, in a semiconductor plant, the purity level would be ppb. That means they would say, I require 1 ppb of oxygen, 1 ppb of carbon monoxide. You require a special purification system and technology which is not available globally and openly. You have to go to a company like Linde or Air Products, and they will supply you this technology. And are you satisfied with this answer?
Definitely, sir.
Okay, thank you.
Sir, what is the future of biogas to the green hydrogen conversion?
No, first of all, they are complementary. They are not in competition. Biogas was there. You know, I saw Gobar gas plant 50 years ago in Tulsi Sham and other places where they have a big gaushala, and then they put up a small gau. Many plants came up. Sarvodaya, under the Sarvodaya Yojana, government of Gujarat and other people set up many plants, but these plants did not work nicely because of several reasons. Main is a corrosion, another is availability of suitable material. For example, you require a special sealing in the holder, and if this holder doesn't work, then you lose the gas. But now, biogas and the compressed biogas is coming up in a big way. It can be a very, very important feedstock for ammonia, for methanol and anything, because the advantage is with the biogas is that you also get carbon dioxide as one of the side products. Am I correct?
Yes, sir.
Yeah. So then you can have methanol, you can have so many other things. But they are not in competition, they are complementary. If whatever is being told about the compressed biogas, the biogas mission, if that is successful, it is going to be a wonderful situation for our country.
Thank you, sir.
Sir, what is the capex required for 100 tons of green hydrogen source?
100 tons per day.
Yes.
100 tons per day green hydrogen means 600 tons ammonia roughly. It could be something like 2,000 crore. There are two bases. One is that GAIL invited a firm quotation for a hydrogen plant almost 3 years ago. I don't know what is the status of that project as of now. It was a 10 megawatt electrolyzer. So 10 megawatt would produce something like 2,000 nm cube hydrogen per hour also. So that was 156 crores. It is equivalent to 25 tons per day of ammonia. So if you take a ratio, what you are talking 100 tons is 600 tons per day of ammonia. Because ammonia molecular weight is 17, hydrogen is 6, so just take that 17 to 3 ratio. So roughly that could be the capex, but exact figure, the availability of cheaper electrolyzer from L&T and Reliance will really decide the cost. Anything from this side?
Sir, I had a question in addition to sir's water question. We have a lot of ocean water and Israel is already using desalinated ocean water. So can we use desalinated ocean water for the same purpose? Desalinated ocean water. Removing salt.
Yeah, see, what is required for a hydrogen electrolyzer is a demineralized water. You know the specification of real water in a plant. If you can make that water suitable to that, you can use any water. And there are experiments going on where they want to produce hydrogen using the sea water. So after some years, probably you may not require a water purification for a hydrogen plant. But that is something going on. Today we don't have any exact figure. But as on today, anything which can make demineralized water can be utilized.
Question number 3.
Hello sir, I am Arman Sayed. So I wanted to ask how can we make green hydrogen production more economical in the near future?
Only two things you require to do. One is start producing cheap electricity from as a renewable source. So wind and solar, you make them more efficient, get the best technology for wind, get the biggest size of wind fans, get best solar products which gives you best efficiency. Say for example, wind power plant. Today if I set up a 1 megawatt power plant of wind, in reality it will produce 0.25 to 0.3 megawatt of power. Roughly we call it a load factor or something is there. It is about 30%. Similarly, solar is also of that order. If you make this better by getting a better technology, so concentrate on that, get best technology, identify or develop. Then battery energy storage system, make it more efficient, utilize cheaper material for battery storages, because that also is an issue. That material is a costly material. And then the electrolyzer. Main electrolyzer is people are developing to find out cheaper material to make the electrodes and the catalyst, and that will make the economical electrolyzer. And this way you can make economical or a optimum green hydrogen cost plant. Okay? Yes.
Sir, yeah, most of the refineries, producing the green hydrogen. So, the end use is producing the electricity, or they're, transporting the green hydrogen to others.
You mean to say refineries are producing green hydrogen?
No, no. This, for example, this project is for producing the green hydrogen, right? So its purpose is to use this in-house, or
Anywhere, wherever you have a requirement of hydrogen, you can use green hydrogen. For example, in a refinery, Right now what they say, you say our Baroda refinery, they are using naphtha, natural gas and off gases to produce hydrogen. Right? Now, if they want to save naphtha, they can put up a hydrogen electrolyzer and start putting that hydrogen into their plant. See, the color doesn't decide the quality of hydrogen. That hydrogen is remain same, molecular weight 2, boiling point minus 252.8, and whatever atomic spectra or molecular spectra you take is same. It is only the source which decides color. So, for refinery hydrocracker or hydrotreater, it doesn't realize the color, it realizes the purity of hydrogen.
Okay, so it is possible, for example, in boiler we are, producing the steam. So it is possible to use the hydrogen to producing the steam rather than using current, coal or briquettes.
See, now, hydrogen calorific value, say for example, natural gas calorific value is something like 9,000 kilocalories per normal cubic meter, or hydrogen calorific value is something like 4,500 kilocalories per nm cube or something like that. Theoretically, you can use, but then whether it is optimum use. See, hydrogen, તમે બધા ખર્ચા કરીને હાઇડ્રોજન બનાવો અને પછી એને તમે બોઇલરમાં નાખો તો એ વ્યાજબી નહીં ને. It's a unnecessary expenditure.
It is a question of optimization. When you are venting the hydrogen from your chimney, it is waste. Rather we should use some uneconomic.
No. That is absolutely okay. What I am saying is that if refinery, we know the situation that the hydrogen plants are in tandem. See, hydrocracker requirement, hydrotreater requirement may change, but you cannot change the load of the hydrogen plant. Say, for example, it is operating at 80% load. Hydrotreater may require 70% require, then 10% is available, which we can utilize in boiler. Absolutely, this is the biggest energy conservation effort. For example, in a Linde-based ammonia technology, pure hydrogen is produced. Pure hydrogen is produced if you are a person from refinery, you know that pressure swing absorption is used to purify the reform gas to make pure hydrogen. That time lot of off gas is coming up. These off gas is put into the reformer. It's absolutely, and everybody would do that. I think his question is little different, as I understand. That you produce green hydrogen and use it in refinery. That is your question. That is not. If you want to replace a naphtha-based hydrogen by a green hydrogen, that could be an economical proposition. But if you want to replace natural gas by green hydrogen in a boiler, it is not an economical proposition. That is the. I hope I'm very clear, right? Okay. Anything else?
Any more questions?
Any question emerging?
Anyone from GSFC University? I guess that's it. Take it. Thank you, sir. Thank you so much. This was really a very enlightening session from sir. And lunch के बाद brainstorming session हो गया, so it was quite good. So we will have a short talk from one of our members, Manju ma'am, regarding sustainability. So she wants to talk something about. Okay, ma'am, the stage is yours. You can just have a 5 minutes talk. Then we'll break for tea. Tea के बाद we have a last session for sir, and sir is waiting since morning, so we will have your session definitely. So one small announcement I wanted to make. Those students, just a minute, I will just have the announcement. Yes, those students who have registered online are requested to collect their souvenirs from our office manager, Shruti ma'am. Shruti ma'am, आप थोड़ा हाथ ऊपर करिए, खड़े हो जाइए. So Shruti ma'am is our office manager. Please collect the souvenirs from her before leaving. And just a minute. and some students, everybody should register their email address and mobile numbers to Shruti ma'am again. So Shruti ma'am is in charge, please, she will coordinate. So students, before leaving, please contact her and then go.
Today we have a Saturday evening talk that we do every Saturday, and today it is on sustainable parametric architecture. So you see a lot of complicated buildings coming up, maybe in Singapore, Hong Kong, abroad. So how those buildings are designed. So it is on sustainable parametric architecture. So please, Vishwa is there. He will give you that QR code. You register so that you will get. It is at 7:30 on Zoom. It's in a hybrid mode. So people can join online and people can join offline also. Thank you.
Good afternoon to one and all present here. Let me tell you, I am not going to speak much on sustainability or anything. I have a few announcements to make, and before that I'll just talk about in brief. I'm sure you all have gained from today's sessions, and there was a common thread which was you might have noticed in all the topics like power conservation, process safety, green hydrogen, that is climate action, right? So to heal and protect our Mother Earth, who is the producer of wealth and holder of treasures for present day and for future generations, let us use the resources mindfully. And in connection with that, I have a few announcements to make. Like you all have received the notepad, right? So those who have not used the notepad, please deposit back at the registration counter. And also one more thing, the ID card which you got with the strap, that also please deposit at the registration counter for climate, for future. That is the only message I wanted to give that conveys everything. For climate, for future. Climate action. Thank you.
Thank you.